So we are going to be talking about Pandas, 2 polars, and DuckDB, which is a question that I'm getting a lot here. So if you want to follow along, there aren't slides per se. Everything that I'm going to be talking about is from a notebook. So if you go to that link that I shared in the resources, that goes to a GitHub page. So and in here you can see is, let me bump up the font here. This is the notebook that I'm going to be presenting from today in my GitHub. And one of the cool things about GitHub is that you can come up here to this code, this green button here, and if you click that, there's this code spaces here, and you can hit plus to create a code space. What this is going to do is going to fire off a virtual machine on GitHub's infrastructure here, and bump up the font. So it is launching VS Code here, and here is the notebook right here. So don't click on this notebook if you launched the code space. Give it a moment. It's actually going to install all the dependencies here. So there you go. You can see it's installing the requirements. This will take a moment for this to run, and then when these requirements are done, you can click that and it will open everything up in Jupyter, and you should be able to follow along from Jupyter right there without having to do any install or anything on your end. Alternatively, this is a Python conference, so I assume a lot of you are familiar with installing packages and whatnot. There's a requirements file. If you pip install that requirements file, you should be able to follow along locally as well. Okay. Awesome. So we got other people from Italy, Greece, UK, Colorado. Oh, hi, Minna. You're right around the corner from me. And Moist Dorset, United Kingdom. Awesome. So I'm excited to, like I said, I'm excited to be here, excited to answer questions or concerns that you might have. I'll try and monitor the chat every now and then. So if you do have a question, feel free to use that chat and let me answer them. Okay, so back to GitHub here. This has finished installing. I can click. I'll just double click on this so you can see how this would work if you're running this at home. Wanted to follow along. So here is the notebook for today, and you can come down. We don't need to run this pip install, but we can come down and run this one right here. And it looks like that ran. And yeah, it looks like we're good to go here. So I'm actually not going to use this. I'm going to run it locally on my machine, but just awesome that you can run that if you want to and follow along. Okay. So I'm going to be talking about Pandas, 2 polars, and DuckDB. A little bit about me. A lot of you might know me as the author of this book, Effective Pandas. To those who have this book or have read it, thank you. I appreciate your support. Just FYI, Effective Pandas 2 is basically done. It's waiting for a final once over by Pandas core developer, and I'm actually in the middle of Effective Polars. So that should be fun. So a little bit about me. Why am I talking about this? So when I graduated from college, I started working with Python, doing data science back in 1999. We were doing natural language processing. This is before things like Spacey and NLTK existed. In 2006, I made a Python OLAP engine at a company, and then later I heard about Pandas, and a lot of things that Pandas were doing were very similar to what I was doing. And so I started using Pandas professionally, started writing books about it, And so I wrote a book called Learning the Pandas Library in 2016. Did some stuff with Spark in 2019. Wrote the second edition of the Pandas cookbook in 2020. In 2021, wrote Effective Pandas. And when I wrote Effective Pandas, at that time I had been teaching and consulting with Pandas for a good chunk of time, and I actually had some pretty strong opinions about Pandas usage and what that should look like. And again, if you've read the book, you're probably familiar with a lot of those, and I'll kind of go over some of them in our course today. And then, last year did quite a bit with QDF. QDF, if you're not familiar with it, is NVIDIA's tool, probably the fastest Pandas implementation, also probably the fastest data frame implementation. Basically implementing the Pandas API on top of GPUs. Did a lot with Modin, was an advisor for a company called Pullers, which basically took the Modin technology and made it so you could run your Pandas code on top of Snowflake. And did some with Pullers as well. So that's kind of where my background is. Again, most of my time these days is spent doing corporate training, consulting, that sort of thing. I like to say that I sell snake oil and teach people to tell lies with data, but I go into big companies and help them learn Python and then help them use the Python data stack, so to speak. So a lot of Pandas, a lot of visualization, a lot of things like XGBoost. Okay, so Pandas 2, for those who aren't aware, came out a while ago. And, if you are using Pandas, we just say that in the chat, so I know like who has familiarity with that. Also, if you want to just say like what domain you're using it with, that would be awesome. And maybe if you're so motivated, you can say like what your favorite feature of Pandas, and maybe the thing that maybe you dislike most about it as well. A lot of people, I'm sure most people know here that Python is a slow language. So we're at the slow language conference, which is kind of weird that Python is a slow language, but like it's also the language that's most used for data science, which is like processing data. And so what's the deal? How does that even happen? And I blame this conference on NumPy. Again, probably preaching to the choir here, but basically what NumPy does is NumPy gives us an escape hatch from the slow language of Python, basically encapsulating an array of numbers. And instead of having, in Python, everything is an object. So when you make an integer, you have an integer object, and there's overhead. There's like 30 bytes of overhead for that object on top of that. And instead of having that per value overhead, what NumPy says is, I'll give you overhead, but it's going to be for a block of memory. And so as long as you stay in the playground of NumPy, you basically get C speeds and a little bit more greater than C memory usage, but close to C memory usage. You don't have to pay that Python penalty. Awesome. So we got people who are doing financial modeling. Very cool. 10 years of Pandas. Wow. You should probably be giving this, Brian. Messing with time series data. Yeah. So Pandas has background in finance, so great for time series data. Everything, rescue boat operations. That's cool. Earth science, replacing Excel. Yeah. Awesome. Okay, so basically NumPy was that escape hatch. NumPy is great for arrays of data, not necessarily great for tabular data or structured data like we see in Excel or spreadsheets or SQL. So Pandas is a way for us to represent heterogeneous data, columnar data, and basically Pandas 1, which I'll generally refer to as Pandas 1 or legacy Pandas in this talk, built on top of NumPy. So Pandas 2 came out a couple months ago. There are a few new features. Sort of the main ones that I think people should be aware of is PyArrow replacing as an optional backend for NumPy. Again, stress that this is optional right now. You kind of have to tell it that you want to use PyArrow, and then copy on write. So what does PyArrow get us at a high level? So I imagine most of you are familiar with PyArrow, but basically it's a standardized in-memory representation of tabular data. The idea being that you can say, like, here is a PyArrow blob that represents some tabular data, and then tools that support the arrow format. Theoretically, you could say, I want to suck this into this tool, and it could do a zero memory copy sort of thing and just load in that memory blob and then be able to access that data from another tool. I think that's kind of cool for my use cases. Not like, do I jump ship from because of an in-memory representation? Not necessarily, but what this also gives us is, like, the PyArrow implementation of this basically has a bunch of tooling to do Pandas and data frame-like operations, and so Pandas 2 can leverage that. And because this arrow specification is basically meant from the ground up, it's built from the ground up for tabular data, it can do a lot of things much faster. So namely, what you get from Arrow for Pandas users is you get better string types. So legacy Pandas, because NumPy doesn't really have a string type to stick in an array, what it would do is make an array, a column for your strings, be a NumPy column that would be backing that, and then in the values of that would be basically pointers to Python string objects. You can think at a high level, not very much more efficient than having like a Python list with strings in it. That's kind of what it was, except instead of a Python list, it was a NumPy array with strings in it. And so when you did string operations, you got, you know, to mess with strings, but those were all Python strings. And so you had the overhead of Python there. PyArrow gives us basically a trim down. So you'll probably say 50 to 70% memory usage for if you use the PyArrow data type for strings. And then the copy on write there is, and Pandas 2 kind of fixed a lot of these copy issues as well, but being just smart about when you do something, do you need to copy it, or can you just pass the original object and then only copy what's changed? It's basically the idea there. So folks who are doing a lot of chaining, probably important to have this copy on write. And if you've read my Effective Pandas book, I'm a pretty big fan of chaining. So again, if you're following along at home and you're using that notebook that I showed you on GitHub, you won't need to do this, but otherwise you probably want to do something like this. For this purpose, for Pandas, the main thing here is when you pip install Pandas and you upgrade it, you'll get Pandas 2. If you want to take advantage of PyArrow, you need to explicitly install PyArrow as a dependency as well. Again, it's an optional backend for Pandas. So I'm going to run this piece of code here, and this is basically making a data frame. So this is some financial data here, like cancel date of some product. When did it start? When did it end? And the revenue and the payments here. And so we're using our friend PD read CSV. And the key part here for Pandas 2 is saying dtype backend is PyArrow. So what does that do? That's telling Pandas to turn on PyArrow as the engine that Pandas is using behind the scenes. So once I've got that, you know, if I look at this, this looks like a Pandas data frame. However, if I come and inspect this D types here, we can see that we have this int64 PyArrow. Note that it's using datetime 64 here, which, to be pedantic, is not a PyArrow type. There's a time NS PyArrow that's the PyArrow type, and then it didn't actually wasn't able to convert this cancel date here. So you see, I told it to parse these things, but kind of did a best effort, but sometimes it kind of fails. So I'm going to go through another step here, and we're going to just like force it here. So I'm going to say let's convert this to date time here, and we're going to replace these NA strings with date time here. So let's try and run that there, and that looks like that works. So on that note, couple other things about the PyArrow backend. So one, it gives us strings, which is probably the big thing, but a lot of people were annoyed that NumPy didn't support missing integer values, and so Arrow supports missing data type sort of from the ground up, and so you can have an int column, like there could be missing values in like this rev or some payments here. And in this case, they don't have missing values, but if they did have missing values, it could still be represented as an integer type. So here I'm going to just jump through some hoops to convert this to the PyArrow type there, and you can see that this is the PyArrow type. Okay. Visha says they're having audio cracking issues. Oh, that's not good. Whoops.
It's okay for us. So
okay.
Yeah.
Okay. Generally, my network's pretty good, so hopefully it's okay. Okay. So again, I can change these types to explicit PyArrow types, so here I might do something like this, where I make this little function called tweak, and I'm just making a change. So this is using that chaining that I was just talking about here, where I'm basically saying, okay, I've got my data frame. I'm going to make this column here. Then I'm going to convert this column to this type. And then I'm also going to convert these other columns to this type. So this is chain of operations. Generally, I'll do this for most data sets that I come across. And I like to write my Pandas code like this, put parentheses around this, escape the new line rules, but just write everything as one method after another. Do you have to do this? No, you don't, but it makes your code look like a recipe. I claim that it makes your code easier to read and use, and once you get used to it, it's going to be very nice. For polars people, chaining is even more strongly encouraged, because when we talk about polars, has the ability to do query optimization on chained query, and can do some cool things with that Pandas, because it's eager, can't really do them. Okay, so this is my basic data set. Again, not particularly interesting data set. It's got like 5 rows of data here, but I'm going to show like a common operation here. So this is like, suppose we were dealing with a company that offers a monthly or subscription service. Customers can cancel at any time, but are billed at the beginning of the month. In this scenario, we need to calculate the unbilled receivables at the end of each month. Revenues that the company has earned but not billed to the customer. So one of my pet peeves is like these Pandas articles that you'll see on the internet. It's like top 20 things you can do with Pandas, and what you'll see is you'll basically see like this listicle of like, do this method, and one of them that they'll tell you about is apply, and they're like, apply is cool because you can pass in a function and you can use the function. So people think that okay, well, I'm just going to use apply for everything, and you can do that. The problem is remember, Python is a slow language, and sort of the key to Pandas is that we have this like NumPy or PyArrow layer, and then we have this Pandas API on top of that. When we're using apply, we're kind of going through that layer, and that slows things down. And so you see people do something like this. Like this is actually kind of a complicated operation here. I mean, I've done more complicated operations, but we're actually doing a bunch of operations on a row here, and this is like normal Python. It's like if this is not missing and the cancel date is less than the period, then we're going to return nan here. If the start date is less than the period and the end date is greater than the period start, and the revenue is greater than sum of payments, then we're going to say return the revenue minus sum of payments. Otherwise, we're going to say 0. And so let me just run this here, and I'm going to make a new column called unbilled receivables, and we can see that it looks like that worked at the end here. We got like a nan up here and a nan down here, and then we got those calculations that look like they worked. So, like I said, a lot of these articles like show this, and then I see people in the wild going off and they're putting apply on everything, which is quite slow. Whereas what we really want to do is something like this. So this is the vectorized version of this, and it's doing some calculations up here, and then it's doing another calculation here, which is basically the conversion of the above to this down here. Issue with this is that like this uses this where, which is kind of weird. It's kind of like, it's not like an if then else, it's more like an else statement, but you do it on what you want to keep. So we're going to stick in what we want to keep, which is like the if part up here, and then this is like the else on that. So we kind of have to rejigger our logic, and it makes like writing, like I'm fine like saying things I don't like about pandas or whatever. The where I think is a little bit awkward, but this works, gives us the same result. And people ask, why do I care? And so I'm going to do a micro benchmark of this, and we're just going to benchmark like the apply version of this versus the vectorized version. You can see like the vectorized version is 200 times faster on my machine doing this, the MacBook Pro M1 chip. So, that might be interesting to you. I mean, this takes, 600 milliseconds, half a second to run. This takes 2 milliseconds. I can barely detect 600 milliseconds, but if you had, this is 150,000 lines or 100,000 lines. If you had a few more, a million lines of code, you can get up to where this actually makes a big difference. And so my general, again, people ask me what they should use. General like benchmarking advice is use what is fast on your machine, and also benchmark on the size of data that you're using in production, because a lot of these things, if you change the numbers, it changes the performance. And what I mean by numbers, if you change the size of the data, change the performance here. I've got a Numba implementation of this. For the sake of time, I'm actually going to just skip this. It speeds it up a little bit more. But okay, yeah, and Angelo says on the code spaces, it's like 4 milliseconds versus 1.3 seconds. So yeah, not quite sure what's going on with the code spaces there. But okay, so if you've got questions about Pandas 2, let me know what those are. Throw those into the chat. And then I'll start talking about polars and sort of comparing and contrasting those. But I just wanted to give you a kind of overview of like what's cool about Pandas 2. Again, from my point of view, you've got that PyArrow, and PyArrow in itself is like the idea of passing around data. For my purposes, sample size 1, not particularly interesting per se, but speed ups on string operations certainly, and memory savings for strings certainly cool. Brian says, any backwards compatibility concerns or gotchas? Yeah, that's a great question. So again, at this point in time, Brian, the PyArrow backend is optional and you have to enable it. So you can take your legacy Pandas code. It should mostly just run. Some things are a little bit more strict in Pandas 2. Basically, like if you're doing an aggregation and you've got like string columns in the aggregation, like you're saying, group by this and then take the mean, it will complain and it will say like, you can't do the mean. And so you have to like add in numeric only is true to say only do the mean on the numeric columns. But other than that, like your pandas, legacy pandas code should work on pandas too. And some of it should be faster without even taking advantage of the PyArrow data types. And then you're going to want to throw in that D type backend. That's going to probably, if you've got a lot of string data, save you memory and also increase your time there. As far as other gotchas there, theoretically, like a lot of things should just work. In practice, most things worked. I would say there maybe are some rough edges. Like I said, I'm finishing the book Effective Pandas 2, and like that has like what I consider more real world examples rather than like 20 things you can do, listicle type things where it's like here's, you know, I don't care about 20 individual things. I care about here's my data and I want to clean it up. And it's not just one thing that I do to it, but it's a bunch of things I do to clean it up or to analyze it. And so that chain, you know, I have a more complicated chain. Do those chains work with Pandas 2? For the most part, they do. There are some gotchas here and there where it's like, you know, we have a Pandas 2 or a PyArrow time in the index, and like exporting that kind of fails. There are some weird things. I've filed a bunch of bugs with the Pandas folks, and a lot of them have been addressed. That's kind of cool that Pandas developers are open to like fixing those things up. So yeah, at a high level, a lot of things should work. There might be some gotchas there, but I think, you know, if you are a heavy Pandas user, this is probably good to try your code out, see if you get like memory savings or speed improvements from this. You probably should, especially if you're like doing copy on write and you've got chaining going on there. Yeah, so Brandon says, any reasons not to use PyArrow? Again, there might be some regressions. Again, like 90% plus your code should work, but there might be some sort of corner cases. Like I said, my experience is that the Pandas developers have been pretty swift to address those things. They want there not to be issues, right? But it's kind of a big change to pull that out, and a lot of people are doing a lot of things with Pandas, so they might not have complete coverage of that. Okay, great questions.
Sorry, Matt, by the way, there's another question in the Q&A section.
Oh, awesome. Yeah, let me address that, and then yeah, and I don't know how to clear off the screen or whatnot, but it says I use Pandas a lot. I want to try pullers for lazy evaluation and the schedule query optimizer, also native backend, but all my logic relies a lot on Pandas index. How can I migrate to pullers or handle the missing index from Luca? Okay, great question. Okay, so I'm not sure if my screen is showing or that question is showing on there. Okay, so look at basically like the indexes there. Let's talk about pullers. Let me see if I address your question. I'll say this at a high level, Luca. It's easy to go from Pandas to pullers and back. If you're using PyArrow 2, theoretically, you should get that 0 copy in there. So if you've got things that are indexed based, you can do those in Pandas and then stick them into pullers where you want. It might help me if you like tell me like what specifically you're using the index for, and then I can possibly give you a better answer. And you can put that in the chat if you want, Luca. Okay, so let's talk about pullers, the pullers library. If I can find my mouse. Okay, there it is. The creator of Pandas wrote a blog post many years ago about like things they hate about Pandas, and I'm going to contrast this with you know, what the creator of Pollars said. So Richie Banks, the creator of Pollars, I heard him talk in a recent talk, and he described Pollars as, I think he described it as like a query engine with a data frame API on top of it. It also has a SQL API on top of it, which I think fundamentally is different than like legacy Pandas and even Pandas 2, where I think Pandas 2, you can describe that as a data frame API. Does it have a query engine? Not really. It's basically like an eager engine, so saying like, we're representing this data, and when you do something, we do the operation. Whereas Pollars is basically saying, we've got 50 years of database research and things like query optimization, predicate pushdown, things like that. And if you squint at this, these operations that we are doing to data frames are basically the same operations that people have been doing to databases for many years. So why wouldn't you leverage that technology? And so again, there's a sort of 10 things I hate about Pandas, and Richie claims that Pollars has addressed all 10 of those things, that those drawbacks of Pandas. I kind of view it as like, Pandas again was written like, here's things I want to do to data. Here's an API that lets me do that, and so we'll do that. Coming back at that, you could think maybe re-enginear that from the ground up and do things a little bit better. So this also leverages Arrow. It does not use PyArrow. It uses a Rust implementation of Arrow. That's one thing to be aware of, is just like where Pandas is sort of, we've got Pandas with basically NumPy or PyArrow under the covers here. This is basically Rust under the covers. And most of the implementation of Pollars is in Rust. There's a good Python basically wrapper around that. But as you'll see, when I show you this Python wrapper, there's nothing really Pythonic about it. And you could imagine that this wrapper could be adapted to any language, basically, because it's not really using features of Python, for better or for worse. Whereas a lot of libraries have said, like, we're going to adapt the Pandas API and kind of take the Pandas API, because for better or for worse, Pandas is the tool that people are using in data science, and the API is kind of the API of tabular data science. Pollars has sort of thrown that out, and we're saying, okay, the API as is has some of these 10 issues, and so we're going to throw out the API. And so Pollars is pretty different than Pandas. And so it has this notion of expressions and context. So you can think of expression as representing a column or operations on column or columns, and then the context is where you do those operations, right? Where you can have, here's an operation that does a filter, and if I do a select with that, it selects the columns as Booleans, right? But if I do a filter with that, it returns the rows where the Booleans are true, sort of thing. I'll show some examples of these expressions. But again, the API is completely different. So people who are saying, like, can I use Pollars instead of Pandas? Yeah, you can, but you've got to port the code. It's not like QPy or Spark, where Spark is implementing the Pandas API, or even Modin, where it's like, we're going to aim to implement Pandas bugs as well, because we want to 100% API coverage there. That's not the case at all. Pollars does have lazy evaluation. So it can run in a lazy mode. It also, by default, will run in an eager mode, well, depending on how you create a data frame. So there is a notion of a data frame. There's a class called data frame. There's also a class called series as well. It just turns out that we basically never use series in Pollars. We only use data frame or a lazy data frame. You can create a lazy data frame as well. And that lazy data frame is kind of one of the key value adds of Pollars. Another way to think of a data frame is like an eager materialized piece of data, right? It's got all the data in there. Where a lazy data frame is, it logically represents data, but it doesn't have rows and columns as is. It's a directed acyclic graph of like operations to do with a logical representation of data. And then when you tell it to materialize or execute, it's going to go through this graph of operations and do some query optimization, and then execute that and give you the data at that point. And because it's written in polars and it's smart from the ground up and knows how to do things like max out your cores, you know, like I said, this is described as a query engine. It has basically worker queues for every thread, and it can do smart things where it's like, okay, we're going to do this group by operation, and we can parallelize that pretty easily. So we're going to throw on for each CPU, it has a worker queue. We're going to throw on these operations to these queues, and we're just going to let them run through. And if one queue you know, finishes, we can move operations from the other ones to max out those CPUs. Like that's the query engine side of it, which Pandas doesn't really have at all, right? And so that's kind of one of the big differences there. And again, you know, people said, you know, you know, with Python like dropping the GIL in the future, or like these sub interpreters, can Python kind of do that with Pandas? I mean, it can to some extent, but you're using Python to manage those threads, whereas this is all done in Rust, and so you don't have that overhead at all. You basically have fast times for doing that. Okay, so I'm going to actually go back to my same example here. Let's see. There's a question here from Ade. Does Polars run in distributed fashion? Can run? So okay, so that's a great question. Probably let me address that at the end with a table. Basically, no, it doesn't. It's not distributed. And when I summarize, I'll kind of go over that, Ade. Okay, so let's load our data here. This looks actually like Pandas, like that. It's not the Pandas API, but I mean, this looks like Pandas here. Instead of Pandas, we have the Polars library, and we're saying read CSV. And if you look at this looks like data frame. This is actually eager, right? This is just a normal data frame. Couple things to note, like it shows you the type here. So these are these arrow strings here, but there is no index on the left-hand side. So one of the things that the Polars folks thought is like, you don't really need an index. And I know a lot of people use an index for various things, but Polars is like, you know, we've been using databases. I mean, databases do have an index, but they're fundamentally different than the notion of a Pandas index. And so like you can think of a Pandas index not as a database index, but like a row label, right? You need a row label. And Polars says, no, you don't need a row label. You know, if you want a row label, you can make a column that has that information in it. And so again, there was a question there, you know, how do I get around that? Yeah, so again, if you can kind of give me some insight into like what you're using the index for, I could probably help answer that question a little bit better. Luca, let me know. Okay, so you know, as I just ran to like the API is different. There is some API consistency. So for example, we can ask like what the D types are, right? And this looks different from what you would get in Pandas. In Pandas, you get back a series. Generally, we don't see series very often in Polars land. Okay. But you can see that these are UTF-8s. They're not string or dates. So if we want to convert these to dates, I'm going to convert them, and this is how I do it. And this looks completely different from Pandas. So we have this with columns. This is a context, and then inside of with columns, we run these expressions. You can think of with columns as like the assign method in Pandas here. But basically, I'm saying, okay, let's represent a column or series of columns, or a group of columns, and so we use this PL call to create an expression. So here I'm saying here's a bunch of columns here, and then these the expression engine has an attribute called str, kind of like Pandas, and it can say like we can parse a date time and convert to a date, and this is the format of that. And so when we do that, this is in eager mode, so it just executes, and you can see that these are converted into dates now, like that. So interesting thing to note is like this says null here. So one of the things that's a little bit different and maybe confusing in polars is that polars has both null and NA, which might be confusing for some Pandas users because Pandas has like is null and is NA, which are synonyms. I kind of wish Pandas didn't have is null at all because nowhere in Pandas do we refer to null things. Polars does have null and they're different from NA. So in polars land, NA is like a floating point that you did some calculation, like 0 divided by 0 for like NumPy is NA. That is NA in polars, and then null means that there's no answer there. So there's a difference between those, and there's like operations is NA and is null, which is a little bit different. So I'm going to show that same operation that we did with like the apply. We're going to do that in polars here. So this is the polars version of that. And polars, you know, it doesn't have an if then else, but it has basically the same thing. You can say when and then and otherwise here, and I can chain these together. So I really wish that Pandas had some syntax like this. It doesn't. You know, there's a bug to kind of, or feature request to do that, but they haven't done that so far. But I can kind of read this as like when this is the case here, and note that I'm not passing in the data frame here, and I'm just saying PL column. I'm saying there is some logical thing that's a column, and the name of it is cancel date, but this is not pointing to the data at all. This is just saying that this is a column. We call this expressions, and we build up these operations on these expressions, and then we tell the query engine to go like figure out how to tie that expression to the actual data and run this. So like here, you know, when this is true, then we want none as a result. When this is true, then we want revenue minus sum of payments. Otherwise, we want 0, and otherwise we want none there. And then down here, we're going to say, you know, this is what I did to convert my columns. And I'm going to say with columns again. Again, you can think of with columns as an assign. And I'm going to just call this function here and make a new column from that. Now, you might think like, why do I need, if you look at the documentation for with columns, you can throw in multiple things into with columns, so you can have multiple expressions here. This is just one expression, but you could have multiple expressions. Why can't I do this in the same expression? And the issue is that, remember, this query engine is going to try and max things out. And when you have with columns, it's going to say, I'm going to create all these columns at the same time. And so because this calc unbilled depends on these being actual dates and not strings there, we need to basically have like a mutex, so to speak, or like this needs to execute before we run this next column creation there. And we can't stick that expression in the same location for that. But if you look at this, you know, we get the same results that we get out there. So I'm going to just make note that I can convert from Pandas really easy. I just say from Pandas here, and then I'm going to do my time it here and run this here. So interesting to note, like this takes on my machine, 5.7 milliseconds, and I think we were at what, like 4 up here. 2. So this is actually slower on polars than it is in Pandas. I'm not quite sure why that is. Yeah, you know, you see a lot of things like polars is fast, and polars, it's not that polars is slow. Polars is fast. It's a more intelligent query engine and can run things on multiple cores, but in this case, it wasn't. And one of the Pandas core developers wrote a blog post, you know, kind of ranting on some of these benchmarks that you see, or benchmarks you see like polars is like 5 to 10x faster on standard benchmarks than Pandas. And they went through the code and like, oh, well, you know, these people are kind of doing things in a dumb way with Pandas. And if you speed them up, then you basically get things that are a same order of magnitude as polars. Now, generally, polars is faster than them. Where polars kind of really shines is group by operations, right? When you're doing a group by, that can happen on multiple cores, and Pandas really isn't smart about doing that. And so that's kind of where Polar speeds up. So the Lucas point, you know, can we take advantage of Polar speed? Yeah, you can convert because they're both using Arrow as a backend. You can get these kind of copy-free conversions from one to another, and you could do your operations in Polars where Pandas is slow, and then push it back into Pandas as needed if you need to do index operations there. But Luca, where you're going to get the biggest speed ups is things like group by. But you can. So I haven't really gone over laziness here. So let me give an example of being lazy here. So I'm just going to write this out to disk here, and here I've got basically my same tweak. So this tweak function is what I had up above. Note that I follow that same thing in like Pandas and Polars. I'm going to make a little function to clean this up. Instead of doing read CSV, I'm going to do the scan CSV. And scan CSV does not return an eager materialized data frame. It returns a lazy data frame here. So when I run this here, and this is the same code, this runs, but instead of giving me results here, it gives me this query plan, right? And you can see what this is doing. This is not particularly interesting because it's not doing too much, but you could imagine you know, where you have maybe a filter and you select different columns and maybe you do some group by or something like that. This is not even, you know, at this point when I run this is not even loaded the file, the CSV file. It's just that this is what I would do. You know, if you got various filters and selects in there, it's smart enough that it can know that like when I read this CSV file, I only need to read these rows and I only need to read these columns, right? So based on these operations, you do things like predicate pushdown and other operations, and you get that specifically because there's a query engine on the back end and because it's lazy and because you're chaining, right? So you're chaining these operations together and it can do the query optimization on all of those operations. Whereas Pandas, you know, you can chain. Does that give you optimization? No, you kind of have to manually do that like our core developer friend did when they looked at those benchmarks. But, you know, if you're smart about how Pandas is doing things, for a lot of things, you can be very close to Polar speed. Okay, so yeah, so the question, does Polars run in distributed fashion? Polars does not run in distributed fashion. So I say Pandas, the library, I contrast that versus Pandas, the API, because there are things that scale out Pandas, the API, to distributed fashion. Things like Modin or Dask, or like that company I worked for, Ponder, would take the API and let you run the API on things like BigQuery or Snowflake, right? So Pandas, the API, has kind of the answer from small data to medium or large data, where my definition of small data, not to get, you know, into the weeds, is small data is data that fits into RAM. Medium data maybe doesn't fit into RAM, it fits on a single machine. Big data doesn't fit on a single machine. Pandas kind of has the answer or solution for all of those scenarios, whereas Polars has the small data, and it does have some spillover. You can have some streaming functionality where you can stream from disk, and so you could imagine you've got sort of the small and medium data, but you don't really have the big data answer there. Now, there is a company behind Polars, and I imagine Richie is probably working on something to do that. But you know, as is right now, when you're working with Polars, you're working with small or medium data. Okay.
Matt, there's another question.
Another question here.
I will show on screen now.
Yeah, I got it there. Nishan, thanks. Is there an advantage using Polars over PySpark? So far, Polars is looking very similar to PySpark, engine, lazy eval, etc. Okay, so great question, Nishan. I mean, we can probably push that question off to our DuckDB part as well. But yeah, I'll kind of answer it here. So again, PySpark kind of, can you run PySpark on a single node? Yeah, you can. It's not going to be as efficient as polars. So I'm actually going to answer this in the context of DuckDB instead of polars here, but you can sort of adapt that. So long story short, DuckDB actually has implemented a PySpark interface on top of DuckDB. That might seem kind of weird, but their thesis is like a lot of people jump the gun on like going to big data, like, oh, we need Hadoop back in the big data days, and then Spark came out. It's like, we need to use Spark because that's what the cool people are doing. And it turns out that a lot of people have data that fits into a single machine, or you can rent a big single machine on the cloud, and you can fit data onto a single machine and not have to worry about this distributed problem and slowing things down, running over network. And so like the DuckDB folks, they have this thesis that, a lot of people are running Spark and they don't need to, but there's a lot of overhead and there's a lot of code in that. Wouldn't it be nice if you could like take your Spark code and just run it on a single machine, but run it fast? And so they have they're kind of doing like the reverse of like the Modin and like that Ponder, where that was taking the Pandas API and putting it to big data. They're taking this big data API and putting it to like small data. And they had an experiment, I think, where they ran their code and benchmarked it on their polars. Again, caveats, benchmarks, whatever. But anyway, they had a benchmark where they ran their Spark query on polars. And to replicate that on a cluster, they needed 30 machines to replicate the speed and performance they got at a single machine there. So again, just sort of demonstrating that, if you can keep your things, if you can use small data or medium data, and Duck also has intelligent spillover to disk, so it does what I call medium data. There's some pretty big performance gains that you get from not having to manage a cluster, that infrastructure and cost, and being able to just run things at quicker clip. And so I think that same thing sort of applies to polars as well. Like, if you can run polars code on a single machine, but polars, again, the API is different than that. And interesting that Spark actually has a Pandas API for compatibility, where they're kind of going to that Pandas API layer, which again, Pandas isn't really built for laziness. I kind of hope that they get there, but I'm not sure that they ever will necessarily get to that lazy query engine side. Okay, great questions. Paolo says, what's the advantages of polars versus Daft? I'm not familiar with Daft. Yeah. So it looks like Daft is some other data frame engine. I feel like I know a lot of these database engines, but I'm not. I'm just searching for it here. Get Daft. Okay. Yeah, I'm not familiar with Daft, so I can't really comment on that. I'll have to check that out. Thanks for the question there. Okay. You would think that someone who makes their money telling people about data frames would know that. Okay. So for the final portion here, I want to talk about DuckDB, which might seem kind of weird. Like, why talk about like a database when we're talking about data frames and tabular data? And again, if you sort of think about like what I just said about polars, and the polars is a query engine with a data frame API on top of it. Well, a query engine, a database is a query engine. And I would say that one of the most advanced analytical query engines right now is actually DuckDB. So DuckDB, for those who aren't familiar with it, you can sort of think of it as, instead of SQLite, which is an in-process transactional database, this is an in-process OLAP or analytical columnar database. So it's basically like you can run SQL in process. So it's like, why would I want to do that? Well, basically, if you can represent, these tabular operations in SQL, you can run them in SQL. And a lot of people have been using SQL for doing tabular manipulation and querying for many years. So it turns out that, yeah, there's a powerful engine with years of research and work behind it. And it's relatively easy to use. And actually, Polars has a SQL API that it ships with. So Polars is kind of like, it can be like SQL-ish. And Duck, like I said, Duck actually has a Spark API on top of that as well. So you have sort of this crossover where people, a lot of people who are doing data frame things are like, we like data frame syntax, but a lot of people like SQL. So, can we get the best of both worlds? So a little bit about the background here, a C++ implementation. It's a single binary. You don't have to install a lot of dependencies. Like in Python, you just say pip install DuckDB, and you don't have to start up a server and do the connection. You just sort of get it for free, which is kind of nice. And then the other thing is that if you look at like these operations, like if I go through like my Effective Pandas book, there's a lot of like group bys and melts and pivots and things like that, which traditionally have been painful for people doing SQL. How do I know that? Because, like I said, in my history, like back around 2006, I wrote like a OLAP engine on top of like MonadDB, which I'm a contributor to SQL Alchemy because I wrote the backend for MonadDB, which is kind of, I would say, like the spiritual lineage sort of for DuckDB way back when, and doing a lot of these operations that are kind of trivial in data frames are kind of a pain traditionally in SQL, and DuckDB has an extended SQL syntax that makes things, like window functions and pivoting really easy to do. So you can basically do your operations that you would do with Pandas or Polars in DuckDB, but you have, I would say, a query engine that's probably faster and more optimized than the Polars query engine. The other thing is, like, Polars, until recently, had a few developers working on it, whereas DuckDB had a lot of developers, and DuckDB got, I don't know, some absurd amount of funding, which may or may not be good, depending on like your view of VC or whatnot. But there's a lot of investment into improving DuckDB, I would say more so than probably both Pandas and Polars combined. Manpower behind the scenes working on DuckDB. So which is kind of cool. Okay, so for our purposes, you can pip install DuckDB. I'm also, because I'm in Jupyter, I'm going to use this JupySQL plugin, which is kind of nice here. So I'm just going to configure that. And we'll just import DuckDB. And then once I have this JupySQL, I can say, like, I want to connect to, like I would do a SQLite, I can say, and in memory DuckDB. And we'll just say select 42 with that line magic there. And this gives me, looks like a data frame. And that's because you see I have this auto pandas. It just converts the result to a pandas data frame here. I can do a cell magic in addition to a line magic here. And I can also, like, say, throw that into a variable. So here's my df variable here from running my query. Okay, so let's do something a little bit more involved here. I'm going to say, okay, drop this table if it exists, the bill table, and then let's do this read CSV auto, right? So there are a bunch of functions that DuckDB has given us that allow us to do operations that traditionally are more of a pain than they would be. Okay, so yeah, let's run this read CSV, and the result is a data frame that says success. Okay, so at this point, there should be a data frame called Bill. Let's just query that. I'm going to say select star from Bill, limit 5. And there we go. Look at this. This looks like a Pandas data frame. Again, that's because it's spitting the results out in Pandas. But this is our data, our friend that we just looked at. Now, we might want to make sure that like this, I mean, this actually says NAT, which is not a time. So you know, we might be okay there. And we could inspect like the Pandas D types of this and capture it as Pandas here, but we kind of want to look at what's going on with the database here. So it turns out that like there's an information schema table. So duck foods itself, or eats its own dog food, I guess. A lot of databases use databases to implement the databases, right? So the metadata is stored in the database here. And so there is a tables column. They're kind of interesting. There's actually an extended sequence or SQL syntax here. If you want to say select star from a table, you can just say from table. You don't have to say select star, which is kind of nice. And you can put like where's on this or whatever. So this is just saying like select star from this. And this says like we have a table called Bill. Okay, so that's that table I just loaded. And there's another table called columns. So I'll just say from columns here. And we can see that, okay, here are our columns. Those look like they're good. And here's the types, and the types are dates. So this is actually kind of nice in that like Polars and Pandas kind of struggled with those dates somewhat, more or less. And DuckDB just sort of slicked them up and didn't really have too much problems here. And Dominique says, you know, what exactly do you mean by medium-sized data sets? Okay, so here's my very basic description, Dominique. Small data fits into RAM on a single machine. Medium data is larger than RAM, but would fit onto disk on a single machine. And then big data doesn't fit onto that. Okay, so Dominique, tools like Polars and Duck have intelligent spillover to disk and support for medium data, but Polars or DuckDB don't really have the scale out in the big data like a cluster of DuckDB or a cluster of Polars, if that makes sense, Dominique. Let me know if that answers your question. Okay, so let's do our complicated query, which was like our unbilled receivables here. And we can do this with our friend case statement here. And this actually, I mean, looks pretty readable compared to like the Pandas, like where, you know, this is just like when, this isn't if, like when this is true, return this. Otherwise, return 0, and otherwise return null here. And let's run that. And there's our unbilled receivables. This is running on our 100,000 rows in there, and it looks like it's doing the right thing there. Okay, so this does have arrow integration. One of the cool things about DuckDB is there's a ton of features. You can, so DuckDB, in addition to being like a query engine, it actually can suck in different things to query against. So it knows how to query directly against Polars or Pandas. So you don't even have to copy it in there. It can use its query logic to query those directly, which is kind of cool. But we also have some arrow integration in here as well. So here I'm going to read our bill data into a Polars data frame. And look at this. I'm just going to say, let's read that from our data frame here. So instead of querying from that Polars connection that we made, I'm going to, or sorry, the DuckDB connection that we made, I'm going to read from this Polars data frame. So select star, and then note here, I'm saying PL at the end. This just converts the result to a Polars data frame. Just for fun, I'm going to actually get rid of the select star because I think I don't need it. Yeah, we can just say from Bill, right? So we can convert from, we can take polars into DuckDB, and we can also get polars out of that. Let's just capture the result here and convert it to pandas as well. And here we can just say df at the end, and we can convert to pandas. Addie says, where can I get a copy of the temp build? I did that up here, Addie. You'll just need to run the cell. Let me find it for you. It is this right here, lazy inquiry optimization. So this is in the polar section. If you run this here, it will write that temp directory, that temp file for you, Addie. Okay. Okay, so that's kind of cool. Like and at this point, you know, if you have your data in polars or pandas, and people like to use SQL, they can write SQL directly against that. If we need to like stick this back into pandas to view this. So one thing is that like neither polars nor DuckDB does, but like pandas does, pandas has visualization, right? Pandas has integration with Matplotlib, and which I think is awesome. I actually prefer to plot using pandas, create Matplotlib plots using pandas rather than using Matplotlib directly, because I think the interface from pandas is actually easier and more intuitive. And often I have my data in pandas data frames already, so why not? So I found like bugs in code from visualization. So I think visualization is awesome. Polars and DuckDB don't have visualization, right? So if I want to visualize something, you know, we can stick it into pandas with one line of code, right? df, and then we can use our pandas.plot to do a plot from pandas very easily. Okay. So that is my DuckDB. Again, DuckDB also has that Spark interface. So I think this is going to be an interesting space to watch. What we've got is sort of pandas, which is the lingua franca. You can kind of say, I'm going to sort of spitball, or this is kind of looking like the no one got fired for buying IBM from a few years ago, or sort of like where pandas is sort of like, this is established technology that a lot of people are using. You know, there are companies that have millions of lines of pandas code. They can't really directly go to polars or DuckDB without doing some engineering, right, to rewrite that. And generally people don't like to rewrite things just to rewrite them if they're working, right? Generally that's not an effective use of engineering resources. We want to create new things and better things. And if things are kind of working using an old technology or whatnot, you can just leave it be and let it run. So I don't see folks like migrating to polars just for fun. You know, there's got to be a compelling use case there. Also, another thing just to realize is that like pandas has had like a 1.0 release, and polars, like polars, the cadence of releases of polars is generally on the order of like 1 or 2 a month, right? And I have had cases where like my polars code has broken and the API has changed, right? So there hasn't been a 1.0 release of polars. Not that I think like there's going to be huge breaking changes there, but it's like this thing is moving pretty fast, right? Pandas releases are kind of every now and then there'll be a release, but it's not you know, at the cadence or clip that polars is going. It's not to say that pandas developers aren't responsive. Certainly they are. Like I said, I've for my effective pandas 2 filed multiple bugs, and most of them have been addressed very swiftly by them. So, you know, if you do have issues with that, highly recommend doing your git turn as an open source user and filing those bugs there. let's see, Giles says, there's some API weirdness with Pandas Pyro, I think due to the incomplete implementation. The DT accessor and Pyro are having durations rather than time deltas. Hopefully that situation will improve. Yeah, yeah. There are, yeah, some of these things where Pyro, it is a little rough. And yeah, again, my advice there, Giles, is you know, open up those lines of communication with the Pandas core developers. You know, if you need to, I mean, it is certainly possible to mix and match, right? You can have a Pandas data frame that has some Pyro columns and it has NumPy columns as well, and you can use both of those. So you know, if the Pyro data isn't working for you, you can do the NumPy stuff, and should be relatively good depending on what you're trying to do. Like the date stuff from NumPy is going to be pretty fast and optimized, so I don't think you're going to lose performance necessarily there. Where the pain might be is like, you know, if you are one of those folks who needs to move the data into something else, right? Like you need to move to Polars or DuckDB. That might be a little bit more tricky, or you might have some actual copying to do if it's in NumPy instead of Pyro under the scenes. Angelo says, probably tangential, but any advice on how you deal with read variables as strings in DuckDB? I need to mass rename a variable. My language server cannot take care of it, but not when dealing with variables in strings. Yeah, so I think what you're asking, Angelo, is that you have to read variables as strings. I need to mass rename a variable. Yeah, I guess I'm not really parsing what your issue is, Angels. Maybe if you could describe it differently, I might be able to help. Galima says, as a beginner, it seems like there are a lot of ways to do similar things for small and medium data sets. Is it best to start with one and learn it well? And if so, are there any that you would recommend, at least initially? Okay, so that's a great question. I'm gonna scroll up a little bit. I've got this little chart that I made here, and this, you know, I made this as an attempt to like hopefully be useful here. So what we've got in this chart, at the bottom we have scale, from small to medium to big, and then on the left-hand side we have API. And thinking about this, it should be a little bit different. This blue box represents the Pandas API, not the Pandas language. Spark is this pink one, and then SQL is this orange one at the bottom. Again, because Spark actually implements some of the Pandas API, there should be some overlap here between the pink and the blue here. But you see like Pandas, QPy, Modin, and Dask sort of goes outside the box a little bit. Like QPy and Modin aim for like 100% API compatibility. Their Dask has some features that are different because it does have some laziness in it. You see that Pandas and QPy are small data, where QPy needs to run on your GPU. Modin actually will run on small data, but because it has some overhead, because it has things for like scaling out data, for really small data, that overhead of like doing the scale out actually slows Modin down relative to Pandas. But like when you start doing a bunch of group bys, then Modin sees improvements over Pandas. So depending on your workload, on small data, Modin might be an improvement, whereas Dask is like, yeah, you can do Dask on smaller data, but you're probably going to want to push Dask onto like big data. So from Spark here, my face is kind of covering it, but you've got like Spark is sort of big data in SQL. You can do SQL Spark, but you can also do the Spark API, which actually has some pandas for big data there. BigQuery, that's Google's big SQL, actually recently announced that they're having a Pandas API as well. So you can kind of see that coming up here, like you can run your Pandas code on BigQuery with that. And then Snowflake, like Snowflake has like Polars or Ponder. I mean, they bought the company Ponder, which is basically running Pandas on top of that. Well, Snowflake hasn't officially released that, so I don't speak for them, and I'm not sure exactly what their plans are. But the technology exists to like run Pandas on top of Snowflake as well. And then you know, Polars does have SQL, right? And Polars works for small and medium data. And then Polars has its own API, right? So it's not the Spark API, it's not the Pandas API, it's its own API as well. And then Duck has SQL, it's great at SQL, it has the Spark API. Duck actually has another API, which it calls the relational API, which is, again, not Pandas nor Polars, but it's another API as well. So those, I think those are two axes of looking at this data, right? Are those the only axes? I mean, other things you might want to look at is like sort of longevity of product or how established it is, or if you have commercial support for those. You know, those might be questions that you want to ask, or even like developers, right? You know, the question of like, you know, if I'm learning something, as like Yelima said, as a beginner, what do I want to learn? And, you know, I think right now, probably, you know, if I'm giving advice as to like, you know, I want to break into the market or something, I think Pandas is going to be, you're going to want to learn Pandas to start off with, just because there are going to be a lot more opportunities with Pandas. Probably should have some SQL as well. So that would be where I would start off with. David says, will your Effective Pandas 2 book use the same data sets as the original edition, or are they all new examples? Yeah, so David, Effective Pandas 2 does have some new chapters, but for the most part, it's taking the existing code and running it in Pandas 2, which has some pros and cons, right? So if you've got Pandas 1, or you got Effective Pandas 1, some of the content will be similar, but I've had to go through every piece of code and make sure that it works with PyData as the backend, right? So I think, you know, for those who are heavy Pandas users and like, here's what the Pandas 1 code, legacy Pandas code looked like, and here's what it looks like with Pandas 2. I think that's actually useful for professional Pandas users who are looking to port their code. And then it has additional chapters on testing and debugging and refactoring that code there.
Sorry to interrupt. I just wanted to give you a heads up that you have about 5 minutes remaining for your presentation. Thank you.
Okay, thank you. Yeah, so you're going to kick me off in 5 minutes here. So you got 5 minutes left to ask questions that you might have, folks. Okay, Angela says, sorry, I meant as in the following DuckDB from Bill PL limit. Bill PL is Polars or Pandas variable, but it's encased in a string, so you lose semantic representation of it as a variable. Okay. You need to mass rename a variable. Oh. So you need to do like some search replace. Yeah, I mean, and you're saying like your whatever, your language server on VS Code, when you rename that variable, doesn't rename the SQL query. Or yeah, so yeah. Yeah, I mean, it is what it is. I guess if you're concerned about that, you know, you can do something where, like, before you do your DuckDB query, you could just make some like the DuckDB data frame and point it to that variable, and then always run your DuckDB query from like not the variable, but the new one that you just created the line before. And then you could sort of be consistent and get the refactoring there, if that makes sense, where you're abstracting the variable name by just making another alias to it. Don't know if that helps or not, Angelo. Okay. Okay. Yeah, let me know what other questions you have. You know, folks who say like which should I use, right? Which of these technologies should I use? And the answer is an unsatisfying, like, it depends, right? You've got 1 million lines of Pandas. Probably if you're in that world, it's not going to make sense to migrate to another system, right? So you probably want to stay in Pandas land, right? You're an established big company. You're looking to hire a bunch of developers. Polars might not be an option there, right? Because there are probably not a lot of Polars developers. SQL might be an option. There might be a lot of SQL people. Pandas might be an option as well, right? You're a small startup. You want to do things quickly, and you want to have things that run fast. Polars might be an option there, right? Or maybe you say, like, I want to use Duck, and then I can use Spark if I need to, or scale out to that. Or you could say, well, I'm going to run it on CuPy. CuPy is going to be faster than Duck or Spark or Polars, and so we're going to stick with a Pandas API, right? And use CuPy to get really fast speedups there. So I didn't demonstrate CuPy here, but again, that's NVIDIA's basically Pandas API, and running that Pandas code on top of that. If you're doing like a string rename, that's going to be a slow operation, like to rename string columns or do replacements on that on a CPU. On a GPU, if you got 600 cores, each of those 600 cores can do change a different name. And so it can run 600 times faster on the GPU. Okay, thanks everyone so much. Again, you can follow me on social media. I'm on LinkedIn. I'm on Twitter. If your team needs training with Pandas or Polars or Duck, please reach out. Matt at Metasync. Again, Effective Pandas 2 coming out soon. Effective Polars in the works as well. Thanks so much for your questions. Have a great rest of your conference. Thanks for letting me be on here. My pleasure.
Yeah.
Thanks, everyone.